Hello and welcome to the second OpenCog tutorial about Economic Attention Allocation. My name is Joel Pitt and this is going to sort of in preparation for the Google Summer of Code 2009. In the last tutorial I talked about the importance updating agent and briefly went over what the difference was between short, long and very long term importance and how stimulus gets converted into those quantities. Now I'm going to talk about an agent called the HebbianUpdatingAgent. And before I go into the details of this that code, I want to say that I'm also going to talk about, at the end of going through each of these mind agents, I'm also going to talk about the hot field network emulator, which uses attention allocation to emulate the behavior of a hot field network. A hot field network is a kind of associative memory, and so that's quite cool, and it's got a visualization demo which will probably be the most whizzy looking of all these videos. Hopefully I'll have that done and you can skip ahead to that if you want to actually just see things in action, but first I'm going to go through and explain each of these mind agents that are involved in it. So this first one is, this one I'm going to talk about now is the HebbianUpdatingAgent, and this explains, this works out what the truth values are of Hebbian links between atoms. And what a Hebbian link is a indication of which atoms have correlation between when they're in the attentional focus. So if you've got one atom, say atom A, which is in the attentional focus, and there's a Hebbian link that's a strong Hebbian link between A and another atom called, say, B, then if A is in the attentional focus and B isn't, then that's an indication that we should possibly have B in the attentional focus too, because they are often useful together. And so another mind agent that I'll talk about is the important diffusion agent, which moves STI and LTI along these Hebbian links. But first you've got to have some way of working out what the values are for these Hebbian links. So this is a pretty simple agent, so this is probably going to be pretty quick tutorial. It's not very complicated. In the future we'll probably have other ways of both creating and updating the link. So that's another shortfall of this agent, is that all it does at the moment is just look at existing Hebbian links, and so we'll need a sort of a Hebbian mining agent which will go through and look at the history of different atoms to try and work out which atoms should have links between them. This one just works on what Hebbian links already exist. So basically the way that it works, you've got the standard interface for run, which the server calls, and then what it does is it grabs all the Hebbian links and works out something called the conjunction, which is basically a value between -1 and 1. So it's basically correlation as well. So if you've got both atoms have the maximum STI that's been seen in the system, then you'd have a full conjunction of 1. You'd actually have that same value if they were both sort of the minimum value as well, so if they're both the minimum STI. But if you had atom A, which had a whole lot of short-term importance, and atom B, which was had very little short-term importance, then you'd have a correlation of -1. That's assuming that A was in the attentional focus and B wasn't. So it's pretty reasonably simple there. There is some little tricky bits, because there are different types of Hebbian links. There are it probably won't say here, but there are the Hebbian links that exist are firstly just straight Hebbian links, and these is kind of like they're a symmetric positive correlation between two links, and because truth values can't have negative values in them, so in order to represent a negative correlation where one is in the attentional focus and another atom isn't, we need an inverse Hebbian link. So those are those two options, and then there are also symmetric and asymmetric versions of each of those. So you could have ones where if A is in the attentional focus, then B should be, but if B is in the attentional focus, then A doesn't necessarily need to be in the attentional focus. And whether these different types of Hebbian links are actually necessary in the end will only be determined by experimentation in the future, but they are there, and I needed them for doing the hot field network demo. Not all of them, but most of them, but for the sake of completeness I decided to put them all on. So there's a couple of parameters to the Hebbian updating agent, and specifically there's the parameters of whether or not to convert links, and so that's related to having these different types of Hebbian links. If you've got a Hebbian link between a positive correlation Hebbian link between A and B, and then B sort of falls. More often you find that B is actually outside of the attentional focus. Do you want to just decrease the truth value of that link until it's 0 and just that's all you do, or do you actually want the Hebbian updating agent to go and say, oh, actually this is now an inverse Hebbian link? So that's basically what convert links does, and it works the other way as well, converting inverse Hebbian links to normal Hebbian links. And there's also a threshold which my mind is blank at the moment about how that works, but that probably indicates how far that has to go before the link is actually converted. So if it's just sort of hanging around a little bit, if it's just slightly below like a very slight inverse correlation after being positive, then it probably won't do that conversion. So if we go through, this is, like I said, pretty simple, some very sort of administration kind of methods. This is the meat of the agent here, I think, but before we go through all that, we'll look at some of these ones. So this is the target conjunction that I was talking about. This just basically works out that -1 to 1 value of how much they're correlated in the past. So it's pretty basic. It's kind of, it won't work for links that have modernarity 2, so that's something that will have to be fixed at some stage, so that we can have Hebbian links that are just kind of like, well, this big group of atoms are all in the attentional focus at the same time, and that will probably save us a bunch of memory and resources too, doing it that way. But trying to do that on a sort of a how far are they correlated makes it a little bit more different, but it's definitely doable. So these things are used basically to support this main function here, which is the Hebbian update. It's a kind of silly name. Anyway, so we have this TC stands for target conjunction, and there's a decay rate. So we don't just work out the new correlation between them. We go and we sort of have a exponential decay to the previous values for the target conjunction. So it's sort of a gradual update. And actually, I know why this is called Hebbian update, is because this used to be called Hebbian mining, the Hebbian mining agent, but since it doesn't actually find new links, it's more appropriate to call it the updating agent, and that's obviously just a search and replace job. So we get all the Hebbian links, go through them all, and then we're working out the current correlation between them, getting the old one, and if they're not the same, then it's obviously different. So we should it's just a way of skipping over if nothing's changed. If we oh right, now I understand what the conversion threshold does. It's actually the minimum STI of the agent before it gets run. So if it's a long-term importance link, we don't really want to just go and replace it. But when we're updating the agent, so because it might have more long-term importance, and yeah, so it might have a very weak association, but we don't want to go and based on past, like the recent correlations, go and replace that with a inverse correlation or something. So this is just going through the specific cases of how to do the conversions. It's kind of tricky, but it's nothing amazing. See, this is the update rule where we multiplying by this decay rate and combining the old and the new. And yeah, and this is here we have, if we're replacing the link, then we have to remove the old one, add a new one. It's still pretty straightforward, and that's pretty much it. So I guess we can just I'll just sign up for this one, a bit shorter now, and the next video will be about the importance of diffusion agents. So this one updates the Hebbian links, and the Hebbian diffusion agent will spread STI and LTI along those links. Thanks for tuning in, and now I will sign off and start recording the next one.